right, hello everyone. Hope you are doing well. We're going to jump right in. 315, how can I graph it? Tables, graphs, and rules. In lesson 314, you practice setting up the correct axes to graph data from a table. Today you will graph a rule by making a table, then by plotting the points from your table on your graph. You will also continue to find patterns in tables and graphs. Now, again, this section of the chapter is working with graphs and should hopefully be something you're getting comfortable doing. This problem is going to start out with something kind of challenging today, so we are going to jump right into it. This is, like I said, kind of tough here, so hang with me here, okay? Problem 343, good tipper. Tips are something you pay someone when you go out to eat. Mr. Wallace needs your help. He is planning to take his new girlfriend out to dinner. He will, of course, leave a tip for the waitstaff at the end of the meal. He decides to create a tip table, which some people do have. They actually have this in their wallet and they just keep it and they look at or in their purse and they look at it when they determine their tip. He wants to create a tip table that will help him quickly determine how much tip to leave. Create a table like the one shown below. What are reasonable values for X? Mr. Wallace needs a tip table that will help him quickly determine a tip for a bill that may occur after a nice dinner for two. Discuss with your team, what do you think? That would be, and we come up with 8 values for this. And so I want you to think about it. I want you to think about the possible values. What numbers could I possibly use that would be reasonable here for leaving a tip? By the way, I do want to let you know there is a handout for this. It's on the 315 resource page. So if you got the packet, please look at the 315 resource page. Otherwise, you should be able to print it out. And on the back, it's actually backwards. We made this handout when we were doing the first 2 problems first, and the second, like 343, we were going to do that second. I'm switching the order around and actually going back to the regular order. So it is on the back of your handout for section 315. So look at 315, find it. You will find this, so you don't have to copy it down. If you want to, you can also print it out. If you don't have either, then you need to copy this table right now, please. So pause the video, copy this table, and then when you're done, unpause it. Otherwise, we're going to keep going, okay? So I do want you to think, if a nice dinner for 2, nice dinner, how much approximately do you think it would cost? And we're picking 8 different values because, you know what, it might depend on where they go to. Nice dinners are usually not going to be at McDonald's, even though sometimes that's how you start off earlier dates, and then you build your way up. You don't go first on your first date to like a really expensive dinner. But let's see some options here. So first option for 2 people, nice dinner. If you go for the cheap route McDonald's, you get $10. I don't know, even $10 doesn't even really cover McDonald's, well, does it? But then maybe 20. You could maybe go 30. We don't necessarily have to stay in order here. We don't have to pay. So let's say they jump from 20 up to a really nice one, 50. And then it's not out of the question to spend $100. Some nice places. I saw a really cool, my wife and I watch cooking shows sometimes, and yes, I know. It's actually kind of interesting to watch some of them. But some of them are talking about these really nice, there's Michelin stars. It's not like the Michelin tires, but there's like really special, extra nice restaurants get Michelin stars. And there was one up in Chicago, and I was like, oh, I wonder how much it would be, or how cool it would be to go to that restaurant. And it was, I'll tell you just saying. So 100 is not out of the ordinary to, even here in Champaign, you can find restaurants that you easily spend $100 on 2 people. Some of you have done that. You could also spend like 120 or 150, maybe even 200. And then, you know what, like I was saying, the nice restaurant, that Michelin star restaurant up in Chicago, it was, what was it? I think it was $350 a person. Now we're not going to go that extreme. Let's go with just $300. Now again, you're thinking, holy cow, how does that work? It is possible, okay? I'm not saying that you're there. Okay? You better not be, but at some point maybe you will. I don't know. Will I take my wife out to that $300 a person restaurant? I don't know. That's a ton of money. It would be like, anyway, moving on. Letter B, Mr. Wallace is planning on leaving a 15% tip. That means for a $10 bill, he would leave a $1.50 tip. Oh man, I already kind of gave you the first value, $1 and, could do, yeah. $1.50 tip. Determine the tip for all the values in your table for part A. This is Mr. Wallace's tip table. Now, I want to sidetrack here, and I want to teach you a trick. This trick is something that will come in very, very handy wherever you go, whatever you do, and it's finding percents. Finding different percents for different quantities. So we're going to kind of piece it together. So let's take one value, like let's take $20. So on your paper, this is not an actual problem, but I do want you to write this down. If I asked you to find, let's go with 5%, 10%, 20%, 25%, 30%. Let's ask you to find the values of $20. Well, I want to teach you a really cool trick, and it focuses on this one right here, finding 10% of a number. Now, some of you already know it. Some of you feel very comfortable doing this. Some of you don't, and that's okay. I want to walk you through it. I want to teach you. Finding 20% or 10% is kind of like dividing a number by 10. And when you divide a number by 10, the cool thing is, because 10% is 1/10 of 100. So when you divide a number by 10, all you do is move the decimal point over one time. Because you're dividing by 10. Dividing by a 1 does not change the number. So the numbers aren't going to change. But if you're dividing by 10, you're making it smaller. And the only way to make the number smaller if you don't change the actual numbers, because you're multiplying by or dividing by 1, is to move the decimal point. So dividing by 10 or finding 10% of a number just requires you to move the decimal point one time to the left. So finding 10% of $20 is $2. So write that down, $2. So now think about how much it would be. Now based on that, once you have that, you can find all these other values relatively easily. So what is 20%? Well, 10% is $2. 20% would be, $4. What about 5%? How much would 5% be? Now think about it. If 10% is $2, 5% would be half of that, or $1. Okay? What about 25%? What can I do for 25%? Oh, wait a minute. I know what 10% is, right? Oh, well, if I know 10%, what would 20% be? Well, that's 4, right? Because I double that. So that's 4, but I need to get to 25. Ooh, so can I look at the 5%? So I can do 20 plus 5. 20 plus 5 is 25, right? So 4 plus 1 would be 5. So a 25% tip would be $5 by combining the 20% and the 5%. Or you could do the 10% twice, right? 10 plus 10 is 20, so 2 plus 2 is 4, plus 5% gives you 25. And I wrote that, or 5, I'm sorry. And last but not least, how about 30? What could you find with 30? Now again, if you have 10% and 20%, you can just add them up, right? 4 plus 2 is 6. Or, hold on. You could also say, oh, well, wait, 10% is 2, so 10 times 3 is 30, so 2 times 3 is 6. Yeah, okay. You could even say, hey, 1 is 5 times 6. 5 times 6 is 30, so 1 times 6 is 6. Cool? All those different options. So once you know how to find 10%, you can find pretty much any percent. Yes, usually the ones that add up to 5 are multiples of 5. That's a key term right there. But it's something that most of the percents are going to be that. Okay? So here's what I want you to do now, really quickly. Will you please find all of these values again? Just, hey, look, we're making it a table. Oh, I should have put that line the other way. That line should have been on the other side of it. My bad. Hold on. Go on. Okay, that works, whatever. Please find all those values. Let's go with $50. All right, when you're done, unpause it and see if you got their answers right. Start by finding 10%, I'm sorry. Start by finding 10% and then go from there. All right, here we go. 10% of $50 would be $5, okay? Once I know 10%, what would 20% be? It'd be double that, so it should be $10. Ooh, now let's go back to 5%. Once I know that 10% is $5, 5% would be half of that, which is $2.50. Now to find $25 or 25%. Well, if 20% is $10 and 5% is $2.50, I add those up and I get $12.50. And to find 30%, oh, well, I can do 10% 3 times, right? 10 times 3 is 30, so 10 times 3 is 30, so 5 times 3 would be $15. Okay? Now, if you did not master this concept, that is okay. But that is a skill I do want you to practice because that is one of the most commonly used math skills that you will have the rest of your life, okay? All right, now using that skill, let's go back to this. Now we're finding 15%. So 15% of these values. I'm gonna walk you through a couple of them and then you're gonna finish filling out the table. So 10% of 20 is 2, and 5% is half of that, so 1. So a 15% tip for $20 would be $3. Okay? Now, what about 50? Try it on your own, and then we'll go over it. If you notice, it's already the value I gave you on the table, right? 10% would be 5. 5% would be $2.50. So add those two up, you get $7.50. Actually, I guess we didn't have that one on there. Okay, I do want you to now pause the video and try to find the remaining 15% of those values right there. Got it? When you're done, unpause it and we'll check it. Okay, so 15% of $100, $15. Of 120, well, 10% is 12. 5% is half of that, 16, or 6, so 6 plus 12 is 18. 10% of 150 is 15, half of that is 750. So put those two together and you get 2250. 10% of 200 is 20, and then 5% would be 10. Put those together, you get 30. 10% of 300 would be 30. Half of that would be 15. Put those together, you get 45. Woo! $45 tip, that'd be pretty nice. And yes, those tips can get rather expensive. Okay, so hopefully you got that table. Hopefully it makes sense how you found that. Let's finish it up here, okay? So I know I told you this is going to be a little longer here. I'm sorry, that's the way it goes, okay? So hang with me here. Mr. Wallace is worried that he will not be able to estimate very quickly if he used this table for unusual amounts, such as $52.48. Kind of a weird number, right? He would like a graph to help him determine a 15% tip for all possible dollar amounts between $10 and $100. With your team, determine how to set up the axes, then graph the points from the tip table. Use the questions below to help guide your discussions. Now, of course, you're not working with a team, so I'm going to guide you a little bit here, and then you're going to finish it up here, so pay attention. Should the tip be graphed on the x-axis or the y-axis? Read the math notes box for this lesson about dependent and independent variables. Help your team decide. So here is the math notes box. I'm going to go ahead and read it, but I do need to get a drink of water here because my throat's drying out. This is a little longer than we usually do, which means class tomorrow will be a little bit shorter here, okay? All right, so when one quantity, such as the height of a redwood tree, depends on the other, such as the number of years after the tree was planted, it is called a dependent variable. That means its value is determined by the value of another variable. The dependent variable is usually graphed on the y-axis. So almost always, 99.9% of the time, dependent is on the y-axis. If the quantity, such as time, does not depend on the other variable, it is referred to as the independent variable, okay, which is graphed on the x-axis. For example, in problem 346, you compared the amount of the dinner with the total amount of the tip. In this case, the tip depends on the amount of the dinner bill. Therefore, the tip is the dependent, while the dinner bill is the independent. So they kind of gave you the answers here, didn't they? So the independent is just kind of on your own. That's just the bill. The bill does not depend on the tip. The tip depends on the bill. So the independent variable goes on the x-axis, the dependent variable goes on the y-axis, okay? So please just be aware of that. Then, which quadrants are useful for this graph? Why? Do I need all 4 quadrants? Well, if I had all 4 quadrants, this allows me to find positive and negative values, right? Wait, do I have negative? Am I going to have a negative bill? I wish. Would I leave a negative tip? Sometimes I wish. But no, so I don't need negative. So what quadrants do I need? I need only positive which would narrow it down to quadrant 1. Do you remember the values here? This is quadrant 1, this is 2, this is 3, this is 4. You need to know those. I only need quadrant 1, okay? Then, what are the greatest and smallest values of x? That must fit on the graph. Oh, well, look at what he said. Between 10 and 100. Now, when I do that, I do go from 0 to 100. Okay, because I always want to start out at 0, not 10. So my graph is going to go from 0 to 100. Think about it. Think about what you might do. How can you scale your axis to create the most effective graph for Mr. Wallace? Now it's a 15% tip. Oh, by the way, how much was 15% of 100? It was $15, right? So, and 15% of 0 would be 0. So, hey, my x-axis, I need to go from 0 to 100. My y-axis, I need to go from 0 to $15. Okay? So, on my table, okay, which you are going to, you have the graph there. Otherwise, you will need some graph paper. I am going to go from 0 and 0, and then I've got to go all the way on x-axis. What did I say? All the way up to 100. Now, I'm not doing this. You are going to finish this off. You're going to find an appropriate scale. Your graph should be a decent size. You should use the vast majority of your graph. Don't you dare go 0, 50, 100, because then you just use this and all of this is wasted. So you need to use more than half of your graph when you are using this. You should use the vast majority of your graph. Do you have to end with 100 on the final line? You don't have to. But you should aim for that, okay? You should really aim for using all of your graph when you're doing this. So you are going to finish this graph. You are going to graph these values here. Now from our table, we went fairly high, but they said you only really needed to go up to 100, okay? So you need to graph these points and have that ready to go tomorrow. Got it? We're going to use this when we talk about, well, we're going to go over this first when you come into class tomorrow. So please make sure you have it. Got it? Thank you for hanging in there. I know this was longer than usual. We will have a slightly shorter one tomorrow, so that should be cool. All right. Thank you very much.